create the free notes of electrical circuit, visit the link in the comment section and install the app for free. Source transformation. Question. Using source transformation, find the current in the 3 ohm resistor in figure. Here in this circuit, we have to find the current through this 3 ohm resistor by using source transformation. Solution. First of all, here we can see this 2 volt and this 4 volt are connected in series. So we can add them. So this will be 4 plus 2 and 4 plus 2 is 6 volt. So this will be removed from here and this will be of 6 volt. Now next here we can see this is the voltage source in series with resistor. So we can convert this voltage source into its equivalent current source. So let's convert this voltage source into its equivalent current source. So here now this resistance is connected in series. So now it will be in parallel here like this and the value remains same, that is 2 ohm, and here this will be a current source and the direction of this current source will be according to the polarity of this voltage source. So here this will be upward because the positive polarity is upward. So it will be like this and current I is equal to V upon R. The value of voltage is 4 volt and the value of resistance is 2 ohm. So this will be 2 ampere. Now we can remove this 4 volt from here. The value of current source is 2 ampere. Now here we can see this 2 ohm and this 2 ohm are connected in parallel. So we can easily solve this. Again we will redraw this. The value of this current source is 2 ampere. Now if we solve this, so it will be like this, 2 multiplied by 2 divided by 2 plus 2. So it will be 1 ohm. So let's replace this by 1 ohm. It will be of 1 ohm. Now again we can convert this current source into its equivalent voltage source. So let's convert this current source into its equivalent voltage source. So here this will be a voltage source and the direction will be like this and voltage V is equal to I into R. So here the value of current I is 2 ampere multiplied by resistance 2 into 1. 2 into 1, this will be 2 volt. So this voltage is 2 volt. Now we can remove this current source from here. Now next is we have to find this current, that is this current I. So according to, we can solve this by using according to KVL. Let's say this is a loop with current I. Now we will apply KVL to the loop. Apply KVL to the loop. So let's say we are starting from this point. So it will be minus 6, then this will be plus, minus, and plus, minus. So minus 6, then plus 2, plus 2i, then plus 3i, then plus 1i, then plus 2 is equal to 0. Now we will solve this and we will get the value of current I. So it will be minus 6 plus 2, it will be minus 4 and this will be 2 plus 3, 5, 5 plus 1, 6. So plus 6i is equal to 0. We take this on right side, so it will be 6i is equal to 4 and I is equal to 4 by 6. So this 4 by 6 is 4 divided by 6 is 0.66. 0.66 ampere is the value of current I. Therefore, I is equal to 0.66 ampere. What we have to find in this question? We have to find, using source transformation, find the current in 3 ohm resistor. So here we have to find this current I, and the value of current I is equal to 0.66 ampere. Check the link in the comment section and install the app for free to get the free notes of electrical circuits. And thanks for watching. Get the free notes of electrical circuits. Check the link in the comment section and install the app for free. Source transformation question. Find the current through 30 ohm resistor. Here in this circuit, we have to find the current through this 30 ohm by using source transformation technique. Solution. Here we can see this 10 volt and this 20 volt. These are connected in series with 20 ohm and 10 ohm respectively. So now we will convert them into its equivalent current source. So let's convert them into its equivalent current source. So it will be like this. Here the 10 ohm resistor is currently connected in series. So it will be connected in parallel with current source. So it will be of 10 ohm. And here we will change this later. First we will solve this. The polarity of this 10 volt is like this. The positive is on upper side and negative on lower side. So the direction of current source will be upward like this. And current I is equal to V upon R. So voltage V is 10 volt and the value of resistance is also 10. So it will be 1 ampere. Now we can erase this 10 volt from here. Now similarly for this 20 ohm will be in parallel. It will be in parallel like this. (20 ohm), and now this voltage source will be converted into current source, and the direction of current source will be upward because here it is positive and here it is negative. So it will be like this, upward, and current I is equal to again V by R. The value of voltage is 20 and the value of resistance is 20. So it will be 20 divided by 20. So it will be 1 ampere. So it will be of 1 ampere. Now we can erase this 20 volt from here. Now here we can see this 1 ampere and this 1 ampere are connected in parallel. So they will get added. It will be like this. Then we will copy this and again to draw this. Let's erase this calculation from here and only write 1 ampere, 1 ampere. Now this 1 ampere and 1 ampere are connected in parallel. So it will be 1 plus 1, 2 ampere. Now we can erase this from here. Since the direction of both the current was same, so that's why we are adding 10. Here we can see this 20 ohm and this 10 ohm are connected in parallel. We will keep this 30 ohm as it is and we will solve only for 20 ohm parallel with 10 ohm. So it will be 20 multiplied by 10 divided by 20 plus 10. So it will be 20 into 10 divided by 20 plus 10. So it is 6.6 ohm. Since it is resistance, so its unit will be ohm. So let's erase this from here and it will be a single resistor of 6.6 ohm. Now we can easily find the current through this 30 ohm by using current division rule. So by using current division rule, let's say this is I30 ohm, I30 ohm, I30 ohm is equal to this current, that is 2 ampere multiplied by parallel branch resistance, that is 6.6 divided by total. So 6.6 plus 30. So if we solve this, so this will be 2 multiplied by 6.6 divided by 6.6 plus 30. So it is 0.36 ampere is the value of I30 ohm. So I30 ohm is equal to 0.36 ampere. So this is how we can find the value of current by using source transformation technique. Check the link in the comment section and install the app for free. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Source transformation question: find current through 8 ohm resistance by using source transformation technique. Here in this circuit, we have to find the current through this 8 ohm. Solution: first of all, we will convert this voltage source into its equivalent current source. Now, when we convert this voltage source to current source, that time this resistance in series will become in parallel. So it will be look like this. This 10 ohm will become in parallel like this. The value of this resistance will remain same, that is 10 ohm, and this voltage source will become a current source, and the direction of current source will be according to the polarity of this voltage source. Here positive here and negative here. So the direction of current source will be upward like this, and current I is equal to V divided by R. The value of voltage is 12 volt and the value of resistance is 10 ohm. So it will be 1.2 ampere. So this current value will be 1.2 ampere. Now similarly, we will do this for this resistance and this voltage source. So now here this resistance is connected in series. So when we make this voltage source to current source, that time it will be in parallel. So this 6 ohm will become parallel like this, 6 ohm, and this voltage source will become a current source, and the direction of that current source will be according to the polarity of this voltage source. So here positive here and negative here. So the direction of current source will be upward like this, and again I is equal to V by R. The value of voltage is 20 and the value of resistance is 6. So here we can directly write, or let's write it like this: I is equal to V by R. V is 20 divided by R is 6. 20 divided by 6, it is 3.3 volt. Here we can write, not volt, 3.3 ampere. 3.3 ampere is the value of this current source. Now here we can see the direction of this current source is upward and the direction of this current source is also upward. That means they have the same current direction. So that's why they get added. So let's add them. Again we will copy this from here, or just simply copy this much part, and here this will become 3.3 ampere and this is 1.2 ampere. Now we add them, so it will be 3.3 plus 1.2. 3.3 plus 1.2, so it is 4.5 ampere. So let's erase this and make it a single current source of 4.5 ampere. It will be of 4.5 ampere. Now here we can see this 6 ohm and this 10 ohm are connected in parallel. We will keep this 8 ohm resistance as it is. Just we will simplify other elements. So it will be 6 ohm parallel with 10 ohm. So it will be 6 multiplied by 10 divided by 6 plus 10. 6 multiplied by 10 divided by 6 plus 10. So it is 3.75. 3.75 ohm is the value of resistance. Again, let's copy this from here. This 3.75 ohm. Let's erase this. This 8 ohm will be here as it is, just we are writing here, and this resistance will become 3.75 ohm. Now we can easily find the current through this 8 ohm by using current division rule. Let's say this current is I 8 ohm. So by using, here we can write, by using current division rule, I 8 ohm is equal to this current, that is 4.5 ampere multiplied by opposite branch resistance. The opposite branch to this is 3.75. 3.75 divided by 3.75 plus this 8. So it will be 4.5 multiplied by 3.75 divided by 3.75 plus 8. So it is 1.436. 1.436. Since it is current, so its unit will be ampere. So therefore, I 8 ohm is equal to 1.436 ampere. So this is how we can find the value of current by using current division rule and source transformation technique. Check the link in the comment section and install the app for free to get the notes of electrical circuits. And thanks for watching. To get the free electrical engineering dictionary app, check the link in the comment section and install the app for free. Source transformation. Question: find the value of current I by using source transformation technique. Solution: here in this circuit, we can convert this current source into its equivalent voltage source. So let's convert this current source into its equivalent voltage source. Now here, when we convert this current source to voltage source, that time it will be like this. Here this will be positive and this will be negative according to the direction of this current, and voltage V is equal to I into R. V is equal to I into R, or here we can write V is equal to I into R. The value of current is 3 ampere and the value of resistance is 4 ohm. So it will be 3 into 4, 12 volt. Here we can write it is 12 volt. Now we can erase this current source. Now next, here we can see this 4 ohm and 6 ohm are connected in series. So we can add them. So let's copy this circuit again. make it a single resistor of 10 ohm. So it will be like this, 10 ohm. Now again we can convert this voltage source into its equivalent current source. So let's convert this voltage source into its equivalent current source. When we convert this voltage source to current source, it will be in parallel with this 10 ohm. So it will be like this. We can draw on this side also. And the direction will be downward, because if we redraw this voltage source, it will be like this. It will be here and it will look something like this, positive here and negative here. It is of 12 volt. Now when we make a current source, so its direction will be downward. Now current I is equal to V by R. The value of voltage is 12 volt and the value of resistance is 10 ohm. So it will be 1.2 ampere. So here this will be 1.2 ampere. 1.2 ampere. Now here we can see this 6 ohm and this 1.2 ohm are connected in parallel. So again let's simplify this. Now here we can see this 1.2 ampere is downward and this 6 ampere is upward. So it will be like this, 6 ampere minus 1.2 ampere. And here we can see, or we can simply write 6 minus 1.2 and it will be equal to 6 minus 1.2 is 4.8 ampere, and since this 6 ampere is greater than this 1.2 and the direction of this 6 ampere is upward, so the resultant will be also upward. And why we are subtracting it? Because the direction of 6 ampere and 1.2 ampere is opposite, that is, this is upward and this is downward. So that's why we are subtracting from higher current minus lower current, and we are giving the direction of higher current, that is bigger current. So the resultant will be 4.8 ampere upward. So let's write 4.8 ampere here, and we can erase this 1.2 ampere now. Now we can easily find the value of current I by using current division rule. So here we can write by using current division rule. So current I is equal to this current, that is 4.8 multiplied by opposite or parallel branch resistance. The opposite or parallel branch to this 8 ohm is this 10 ohm. So 10 divided by 10 plus 8. So if we solve this, we get I is equal to 4.8 multiplied by 10 divided by 10 plus 8. So it is 2.6 ampere is the value of current I. So this is how we can find the current by using source transformation technique. Check the link in the comment section and install the electrical engineering dictionary app for free. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Source transformation. Question: find the value of current I by using source transformation technique. Solution: As we can see, this 1 ohm and 2 ohm are connected in series. So it will be a single resistor of 3 ohm. So let's make it a single resistor of 3 ohm. Now here we can see, we can convert this voltage source into its equivalent current source. Also we can convert this voltage source into its equivalent current source. Now let's convert this two voltage sources into its equivalent current source. So when we convert a voltage source, that time this resistor will be in parallel. It will be like this. The resistance value will remain same, that is 3 ohm, and we can erase this resistor now. And now this voltage source will be turned into a current source, and its direction will be according to its polarity. So it will be upward because positive here and negative here. Now current I is equal to V by R. The value of voltage is 5 and the value of resistance is 3. So it will be 5 divided by 3. So 5 divided by 3 is 1.6 ampere. So it will be of 1.6 ampere. Now we can erase this voltage source. Similarly, here when we are converting this voltage source to current source, that time this 2 ohm resistor will be in parallel. So it will be of 2 ohm. Now we can convert this voltage source into its equivalent current source, and the direction of this current source will be according to the direction of this voltage source, according to the polarity of this voltage source, that is upward because positive here and negative here. So it will be I is equal to V by R. V value is 4 and the resistance value is 2. So it will be of 2 ampere. We can erase this voltage source now. As we can see, this current source and this current source are connected in parallel. Now the direction of this current source is upward and also the direction of this current source is upward. So both the current source directions are same, so we will add them and make it a single current source. So let's copy this circuit again. We can erase this current source and we will add it here. So it will be 1.6 plus 2. So 1.6 plus 2, it will be 3.6. 3.6 ampere. 3.6 ampere. And we can erase this current source now. Also here we can see this 3 ohm and this 2 ohm are connected in parallel. We will skip this 3 ohm resistor because we have to find this current I. So this will be 3 ohm parallel with 2 ohm. So it will be 3 into 2 divided by 3 plus 2. 3 into 2 divided by 3 plus 2. So it is 1.2 ohm. 1.2 ohm. Now let's make it a single resistor. Again, copy this circuit from here. Now we will erase this. Let's erase this resistor here. And this resistance value will be now 1.2 ohm. 1.2 ohm. Now we have to find this current I. So by using current division rule. By using current division rule. So by using current division rule, this I is equal to this current, that is 3.6 multiplied by opposite branch resistance. The opposite or parallel branch to this 3 ohm is 1.2 ohm. So 1.2 divided by 1.2 plus 3. If we solve this, so we get I is equal to 3.6 multiplied by 1.2 divided by 1.2 plus 3. So it is 1.028. 1.028 ampere is the value of current I. So this is how we can find the value of current I by using source transformation technique. Check the link in the comment section and install the app for free. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Source transformation. Question: find current through 8 ohm resistance. Here in this circuit, we have to find the current through this 8 ohm resistance by using source transformation technique. Solution: first of all, here we can see we can convert this voltage source into its equivalent current source. So when we convert voltage source to current source, that time this series resistor will be converted into parallel resistor. So this 6 ohm will be in parallel with this 6 ohm will be in parallel with this current source. Currently this is a voltage source, but we have to convert it into its equivalent current source. The direction of this current source will be according to the polarity of this voltage source. So it will be like this, positive upward here. So the direction will be upward. And we know that I is equal to V by R. The value of voltage is 20 and the value of resistance is 6. So it is 20 divided by 6. 20 divided by 6. That means it is 10 by 3 we can write. 10 divided by 3 ampere. So it will be a 10 divided by 3 ampere. Now we can erase this voltage source from here. Here also we can do the same. Currently this 10 ohm is in series, so it will be in parallel. So it will be like this. And the resistance value will remain same, that is 10 ohm. And this voltage source will be converted into its equivalent current source. So it will be like this. The direction of this current source will be according to the polarity of this voltage source. So it will be like this. I is equal to V by R. The value of voltage is 12 and the value of resistance is 10. So it will be 1.2 ampere. Here we can see this current source and this current source is connected in parallel. Also this 6 ohm and this 10 ohm is connected in parallel. We will keep this 8 ohm as it is because we have to find this current I 8 ohm. So again let's copy this circuit from here. And now this time again we will write this current source value, that is 1.2 ampere here. Now we will solve this current source and this current source. Since they are connected in parallel, so their equivalent current source will be in upward direction and it will be 10.10 by 3 plus 1.2. Now we can erase this current source and the direction will be upward. Also we can erase this one. So if we solve this, so we get 10 by 3 plus 1.2. So it is 68 by 15. 68 divided by 15. ampere. Also here we can see this 6 ohm and 10 ohm are connected in parallel. So 6 ohm parallel with 10 ohm. So it will be 6 into 10 divided by 6 plus 10. 6 into 10 divided by 6 plus 10. So it is 3.75. 3.75 ampere. Not ampere, this will be 3.75 ohm because it is resistance. So again we will copy this circuit one more time. And now we will make a simple single resistor of 3.75 ohm. Now we can easily find the value of I8 ohm by using current division rule. So by using current division rule, by using current division rule, here we can write I8 ohm is equal to this current, that is 68 by 15 into opposite branch resistance, that is 3.75 divided by 3.75 plus 8. So if we solve this, we get I8 ohm is equal to 68 divided by 15 multiplied by 3.75 divided by 3.75 plus 8. So it is 1.446. 1.446, and since it is current, so its unit will be ampere. So this is how we can find the value of current by using source transformation technique. Check the link in the comment section and install the app for free. Thanks for watching.